All right, before I do anything, it says, differentiate the Maclaurin series. Well, let me write the Maclaurin series down for this. And I want to remind you that we're looking at this geometric guy. What's it going to be? 1 plus u squared plus u cubed plus yada, yada, yada. Let me write it down for you. And I'll certainly simplify it before I differentiate it. So you can get 1 plus 6x plus 6 squared x squared plus 6 cubed x cubed plus yada, yada, yada. All right? Now, what does it say to do? It says differentiate it, right, twice. Now, for me to do that, I do not want to use the quotient rule. I'm going to rewrite this as 1 minus 6x to the minus 1. And I'm going to start differentiating it and see what happens. Right, so I'm going to differentiate this thing. What do you get? Minus 1 minus 6x to the minus 2 times minus 6. I'm going to simplify that now. What do you get? You get 6, 1 minus 6x to the minus 2. All right, I'm going to get my eraser out. I erase this business over here. I don't need that anymore. And let me differentiate the other side, which should be a lot easier for me to do, by the way. You get 6, right? Plus 2 times 6 squared x plus 3 times 6 cubed x squared. I think I'm going to write the next term down for you. 4, relatively simple pattern, right? 6, well, what's that going to be? That'd be 6 to the 4th power, right? See the pattern here. You're seeing it, right? All right, and what do you get over here? X cubed then. Wow. Let's keep going. It said twice, right? So what do you get over here? Minus 12. 1 minus 6x minus 3 times minus 6. Well, I think I can do that. And what do you get there? Let's be careful about that. You're going to get a positive number. And 6 times 12, I'm going to write a little funny for you. I'm going to write it as 6 squared times 2. Because minus 12 times minus 6 is definitely a positive number. 12 is 2 times 6. 2 times 6 times 6 is 6 squared times 2. And then I'm going to put a dot here and 1 over 1 minus 6x cubed. All right, I just differentiate the left side. We got to differentiate the right side now. What are you going to get over there? 2 times 6 squared plus 3 times 2 times 6 cubed x. There's a pattern to this as well, by the way. Plus 4 times 3 times, by the way, this goes on. I can't have enough times. I lost track. 4 times 3 times 6 to the 4, x squared. All right? So let me write that down. 2, 6 squared, plus 3. You know what? I want them all to look sort of the same. So I'm going to erase this over here. I'm going to say 2 times 1. And I'm going to say there's no x there. And I'm going to say this is 3 times 2, 6 cubed, and there's 1x. And then I'm going to say 4 times 3 6 to the 4th power, x squared. And by the way, I'm going to say at this point it's pretty predictable. The next one should be, 5 times 4 times 6 to the 5, x cubed, yada, yada, yada. What I want to do now, though, is I want to divide both sides by 6 squared, n to 2. All right? And I think I got a series now. Let's write it down for you. This is the series you're asking for. By the way, I'm going to leave it this way. And again, we'll talk about it in a second. 2 times 1 over 2, no x. I'll put x to the 0, though. Plus 3 times 2 over 2, 1 factor of x. Whoops, sorry, I forgot somebody. That's going to be a 6 there. And I'll put a 6, 0 here. That's a 6, 1. Let's put the next one down. 4 times 3 times 6 squared, x squared over 2. And I think I got a really nice pattern here. I want to keep going and see if I have some space over here. You know what I'm going to do? I'm just going to erase what's up here. I'm kind of done with that. And if I made a mistake, I'm done with it. I wouldn't go back over that again. In other words, if I made a mistake in my work, I would just simply say, gee, I'll write something else down. Another set of work, not look at my work. Unless it was a small error, then I'd look for it. So let's take a look at it. And I'm going to pull out a half. I'll write that down first. I'll put a sum down now. I'm going to say n equals 0 to infinity. I want to point out what I took care of so far. This. That's all I took care of. I want to concentrate on this, though. And I think I see that. And I'll write this down for you. I'm going to say it looks like 6x to the n. And I'd get those things over there. I'd get 6x0, 6x1, 6x2, so forth and so on. Now let's look at these other guys. You got, 2 times 1, 3 times 2, 4 times 3. So I'm going to say it looks like, and I'll be careful about it, it looks like n plus 2 and n plus 1. And before I say that's what it is, I want to see if that's what it is. All right, so if I took n to be 0, I'd get 2 times 1. That looks okay. If I took n to be 1, I'd get 3 times 2. That looks okay. If n is 2, I'd get 4 times 3. So it seems like it's working out okay. And what I want to do now is just maybe rewrite a little tiny little bit, and then we'll talk about the answer. 1/2 sum n equals 0 to infinity n plus 1 n plus 2 6x to the nth power. A little box in that. By the way, they didn't ask for interval conversion, so I'm not going to go through that with you. But let's take a look, see how we did. And let's take a look. And I think we got it written over here. Oh, by the way, I pulled the 2 on the outside, but that's okay. You don't need to do that if you don't want to. And what do you get over here? Did I get the right thing? N plus 1, n plus 2? I did. And 6x to the n? Yeah, we got it. We're good to go to the next question. Thank you.